Thanks for the very generous support and all the love. Thanks for keeping the passion of mathematics alive. Thank you. I am Anil Kumar. Welcome to my YouTube channel. We are serving you absolutely free for the last 15 years. Let me thank all the viewers and subscribers for their great contributions. Keep supporting. We will be posting, as you know, a video every day. In this video, we are going to understand the concept of effective rate. So, in this series on compound interest applications, you'll find that effective rate is something which is not really covered in many videos. So, here are two examples. First, I'm sharing with you example 2, which says Bank A charges 11.2% interest compounded semi annually, and Bank B charges 11% interest compounded monthly. Which bank is providing better rate to borrow money? Extremely important real life situation. Perfect. To understand the concept, I'll take a simpler question first, right? And then we'll get into this. So here is a very simple question so that we understand how do we find effective rate. And once we know how to find effective rate, we can do the comparison and solve example 2. So here is example 1, which says find the effective rate corresponding to the stated rate of 8% compounded quarterly. So 8% compounded quarterly is the stated rate. But effectively, since it is being compounded quarterly, you get better returns than just 8%. And what really you get is the effective rate, right? Effective rate is the compounded interest on $1 deposited over a period of 1 year, right? So that gives you some idea of what effective rate is, right? So makes sense. Basically, the concept is something like this. Any amount after the end of the year will be principal plus interest, right? Now, if I calculate the interest, it will be amount minus the principal. Now, let us say that the principal is $1 only, right? And the duration, the time duration t, is also equal to just 1 year, okay? In that case, what we have is that I will be equal to P R T, right? P and T both are 1, right? So basically, if P equals to 1, right, and T equals to 1, then the interest will be equal to the rate of interest, effective rate, right? Do you get the idea? So in that case, we can say that this is like PRT, right, equals to A minus P. So that means 1 into R into 1, right, is equals to A minus P. You get the idea. And therefore, R, which we are calling as effective rate, is equal to what? R, the effective rate is amount which you get after 1 year on $1, right, minus the principal. And what is amount? Well, this is the formula, compound interest formula on the amount, right? So the effective rate, which is equal to amount minus principal, since principal is $1, correct? Therefore, the formula becomes effective rate is 1 plus r over n to the power of n minus 1, where n is the compounding period, right? So effective rate will be same if it is compounded once a year. But if it is compounded monthly, then n will be 12, and so we'll have a much better investment, right? So with that, let's now calculate the effective rate in the given scenario, right? So let's calculate it now. So in this case, we want to find the effective rate for 8%, right? So the rate of interest is given to us as 8%, which is 0.08, and it is being compounded quarterly, right? So the n is equal to 4, right? And we know that the principal p is also equal to 1, right? We are seeing what happens to 1, right? So effective rate RE, as you know, the formula is right there, 1 plus R, which is 0.08 over 4, right, to the power of 4. We are seeing what is the value after 1 year, minus 1. Perfect. So that is how we'll calculate the effective rate. So I hope the formula is clear, right? So 0.08 divided by 4, and to this we are going to add 1. This is to the power of 4, right? And from here we'll take away 1. And what we really get is 0.0824, right? So we could write 8243, for example, right? So we can say that the effective rate is equal to, in percent, it will be 8.24%. You can round like this. Do you see that? So instead of 8, we are actually getting advantage since it was compounded quarterly, right? So it makes sense. Compounded quarterly means n is 4, and that is how it makes a difference. We get additional 0.24% on the investment. Perfect. Now I think it is absolutely clear. Now here is the summary of what we just did and talked about, right? So we have taken the same example, very simple to understand, and here you see I've documented what I was just saying, right? If $1 is deposited at the rate of 8% compounded quarterly, then at the end of the year, its value is $1.0824, an increase in 8.24% on the investment. This increase is higher than the stated rate of 8%. To differentiate between these, 8% is called, so 8% will be called nominal or stated rate, right, of interest, and 8.24 is called effective rate or annual percentage return, APR. Now APR is used very commonly in many financial applications. So that is how you find APR. You get the idea. So here is the result of 8% compounded quarterly. Makes sense, right? Now with this concept, I think you can easily do question number 2. So when you look at this question, we say Bank A charges 11.2% interest compounded semi-annually, right? So let's summarize this. So Bank A charges 11.2%, right? And that too semi-annually. And that really means what? Semi-annually means that the value of n is 1, right? So the rate is 0.112 and n is equal to 2, right? In the given formula, right? So we are using this particular formula. Perfect. Effective rate 1 plus r over n to the power of n minus 1. Value of $1 on this investment is what after an year? To be very straightforward on this command, right? So on the other, we have Bank B, right? So in Bank B, the status is we have 11%. However, it is compounded monthly, right? So it is monthly. That means rate of interest is 0.11 and the value of n is equal to 12. Perfect. So that is how we have all the parameters, right? This is because we have 11%, right, which is compounded monthly. Perfect. Apply the formula. Hmm? So when you apply the formula, you get relative rate equals to 1 plus 0.112 over 2, correct, square, minus 1. And in the other case, you get the relative rate for Bank B, let's say. Let's call this A, right? Is equal to 1 plus r over 12 to the power of 12. There are 12 compounding periods in this case. And calculate. Perfect. When you calculate, you get both the values. You know what result you get? Hmm? So just do the calculations. We have 0.112 divided by 2, right? And then add 1 to it, perfect, and then square it, and then take away 1, right? So minus 1. And what we get is, in decimals, 0.115136. Correct. That is what we get. It's good to write it to at least 4 decimal places, right? Let's do the other calculation. So rate, let me write down here rate, but zero point 0.1, sorry, 0.11. 0.11 divided by 12 plus 1, exponent is 12, and then we take away 1. And what we get is 0.115719. You see that? So clearly, if we compare these two values, we get 11.51% here, and here we get 11.57%. Correct. So that is better, right? Now, in this case, I mean higher, right? So in this case, since you are borrowing the money, right? So since you are borrowing the money, you should pay less interest. So the first option is actually better. It looks 11.2% will be higher, but no, it is even better since it is compounded only semi annually. You get the idea. The other one, which is compounded monthly, will result into higher interest. So I hope that makes a lot of sense, right? So here is the complete solution of this particular question. Calculations neatly done for you. As we just calculated, the effective rate for the first is 11.513%, and for the second, the effective rate is 11.57%. And therefore, if you need to borrow money, you should be borrowing from the bank A, which is compounded semi annually, rather than from bank B, which offers 11%, but it is compounded monthly. I hope it all makes sense. And the concept of effective rate is absolutely clear to you. Feel free to write your comment, share your views. In case you want to learn from me, you may send an email on globalmathinstitute@gmail.com. We are developing our website, Global Math Institute, so your donations are going towards our development of the website and providing you with even better structure of information. I hope you find this video interesting and useful. Feel free to like and subscribe to our videos. Thank you and all the best.